Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 5 on comparing samples. Now this really gets into the heart of statistics, so without further ado, let's get right into it. Now, one of the most common situations in statistics involves collecting sample data from two groups, or two populations if you will, and then comparing the statistics of the two samples, really in order to then infer something about the differences between the two populations. So let's take a look at kind of a classic example in exercise number 1. A company designs a weight loss drug and decides to test it on two groups. Subjects in Group A exercise daily for 30 minutes and subjects in Group B exercise daily for 30 minutes and take the drug. The distributions of weight loss for the subjects in each group after 8 weeks is shown. All right, so just keep in mind, right, for Group A, we're talking about those who exercised daily, right, for 30 minutes. For Group B, we're talking about the people who exercised daily for 30 minutes and took this weight loss drug. And these two, box plots show us how their weight loss was distributed in terms of pounds after 8 weeks. Awesome, right? So let's take a look at letter A. Based on the means for both groups, is there evidence that the drug helps increase weight loss? Explain. All right, great. Well, pause the video now and tell me based on the means whether or not there's evidence that the drug helps with weight loss. And the answer is sure, yeah. The mean weight loss here was 7.1 pounds. The mean weight loss here was 5.9 pounds. So yes, yes, the mean for Group B was 1.2 pounds more than for Group A. So yeah, at the end of the day, right? I mean, if I was just comparing these two groups and all I knew were the means, and they said, well, the average weight loss for this group who took the drug was 7.1 pounds, and the average weight loss for this group that didn't take the drug was 5.9 pounds, I would say, all right, yeah. On average, people in this group lost more weight than people in the other group. All right, letter B. Are there any reasons why we might not want to use the means for comparison? Explain. All right. Well, again, let me kind of just pan up here a little bit. Would there be any reason why we might not want to use the means? Pause the video now and think about this a bit. Well, the answer would be yes. And the reason why is because it appears that Group B has an outlier in it, right? Look at the length of that tail on this box plot, right? That tail is really far out, indicating that this person here who seemed to lose 18 pounds, right? The maximum weight loss in Group B was 18 pounds. That looks like it's an outlier. So yes, because it appears that Group B has an outlier. And we talked about the fact in a previous lesson that outliers, especially if there's only one of them in one direction, will pull the mean up in that direction. And in fact, right, this mean is probably significantly larger than the mean of Group A simply due to that outlier. Okay, so now let's talk about letter C. How would you characterize the variation within each data set? Is it roughly the same, or is the variation markedly higher in one group than the other? Let me kind of move this over here. What do you think? Pause the video now and think about this a bit. Well, again, this one's kind of interesting, right? Because we've got two very good measures of variation. One of them is the interquartile range, and the other one is the standard deviation. Now, you can probably visually tell the interquartile range is the width of the box in a box diagram. And for those two, the interquartile range is roughly the same, indicating that really the variation in the two groups, at least in the middle half of the data, is roughly the same. On the other hand, the other measurement of variation we have is the standard deviation. And the standard deviation in this particular group, being 6.3, is considerably higher than the standard deviation in that group. So, I would say this. Oops. All I'm trying to do is move that. The variation as measured by the IQR is almost the same for the two groups, but the standard deviation I cannot get that. Standard deviation is greater for group B. All right. So maybe that's a little bit of a wish-washy answer, right? Looks like the variation is roughly the same if we're only thinking about the IQR. On the other hand, if we consider the standard deviation, it seems like there's a much greater amount of variation for group B. Letter D. Make a statement regarding whether the evidence in the samples suggests that the drug increases weight loss. All right, so this is what it really boils down to, right? The statistical question is, does taking this drug increase weight loss, right? And of course, that's a statistical question because how much weight is lost, right, varies amongst the people that take the drug and amongst the people that don't take the drug. So, is there sufficient evidence that suggests that the drug increases weight loss? Pause the video now and make a determination on that. All right, well, my answer is it doesn't, right? So I would say there is not enough evidence to conclude the drug increases weight loss. And I'm going to say because the medians, or because the median weight loss is very close between the two groups, right? And of course, we don't want to use the mean because we've got the outlier, right? And in fact, the difference between the two medians is so small compared to the overall variation as measured by either the standard deviations or the IQR, that really the difference between those two medians really isn't significant enough to conclude that the drug weight loss the weight loss due to the drug is significant. Okay, let's keep going. Got a little tongue-tied there. Okay, let's take a look at exercise number 2. Ethan is investigating the following question. Is gasoline more expensive in New York than in New Jersey? He collects per gallon gasoline costs for 200 gas stations in New York and for 200 gas stations in New Jersey. The distribution of the costs for both states are shown in the histograms below. All right, cool. So let's take a look at these things a little bit before we start answering the questions, right? We've got our distribution of gasoline prices per gallon for New York in blue. We've got the distribution in red. We've got a whole bunch of statistics here. Let's go right to the board so we can take a look at those statistics a little bit clearer. right? So for New York, we've got a mean of 3.74. For New Jersey, a mean of 3.25, standard deviation of 0.25 and 0.31, medians of 3.73 and 3.26, and first and second quartile values. Those are actually the first and the third quartile values. I apologize for that. The second quartile values are just the medians. So those are my third quartile values, actually. So we've got, all of these things for our two distributions, okay? And again, these are the kind of things that a statistics program can easily give us, so we don't need to particularly calculate them for ourselves. Now let's take a look finally at letter A. Construct an interval for both samples that represents all values within one standard deviation of the mean. Recall that these would be considered the range of typical values within the data set. Okay, awesome. So pause the video now and construct that one standard deviation interval for New York and one standard deviation interval for New Jersey, and then we'll talk about them. All right, so for New York, and we'll label them. For New York, right, we've got a mean of 3.74 and a standard deviation of 0.25. So I'm just going to subtract that and add that, and we'll figure those out in just a moment. Okay, and then I'm going to set up the same calculation over here for New Jersey. I've been good to give myself a little more room, but that's okay. So my mean is 3.25 and then minus 0.31 and 3.25 plus 0.31. Okay, let me just bail out real quick here. I think I'll, just clearing out my calculator here a bit. All right, so we've got our 3.74 minus 0.25. And we'll get the results back on the screen in a second. Right, so I've got 3.49 to 3.99. And likewise now for New Jersey, we've got 3.25 minus 0.31 and 3.25 plus 0.31, and that's 294 to 356. All right. So again, right, important to be able to think about these and understand what they're telling us, right? What we're saying is that not all, but like good 2/3 of all gas prices in New York are going to be between $3.49 per gallon and $3.99 a gallon. And in New Jersey, they're going to be between $2.94 a gallon and $3.56 a gallon. All right, excellent. So, letter B. Is it reasonable, based on the shapes of the two distributions, to use the intervals in A to compare the typical cost of gasoline in the two states, why or why not? All right, pause the video now and, would those be, right, would it be reasonable to use these intervals to compare the typical prices? Pause the video now and see what you think. All right, and the answer is yes. And the reason why is because both of these things are symmetric, or mostly symmetric, right? They're not perfectly symmetric. Neither one of them are perfectly symmetric. But neither one of them has serious skew going in either direction, and it doesn't appear that either one of them have any obvious outliers, right? And that's where you really want to boil down to, like, why wouldn't we want to use these things? We wouldn't want to use these if we had either skew or outliers in our distributions. So the answer is yes, because the two distributions are mostly symmetric. Mostly. Yeah, maybe not completely, but mostly symmetric. All right. So, letter C. How would you characterize the variation within each data set? Is it roughly the same? Or is the variation markedly higher in one group than in the other? Explain. Okay, well, what do you think? Pause the video now and consider that question. All right, and I would say that they're roughly the same, right? Here we've got a standard deviation that's 0.25. Here we've got a standard deviation that's 0.31. So they're roughly the same. Roughly the same. Perhaps a bit larger for New Jersey, since its standard deviation is a small bit larger. But it's not much. Remember, we're talking about dollars and cents here. The standard deviation for New Jersey is 6 cents higher per gallon than it is for New York. Now, we could also calculate the interquartile range. Remember, those aren't second quartile, they're third quartile. So we could subtract those two. That would be 31 cents for that interquartile range, and for that it would be 44 cents. So 31 cents versus 44 cents. Again, pretty close in terms of the grander scheme of things. If we were seeing that like the interquartile range for one of them was 25 cents and the other one was $2.32, oh, those would be very, very much different. All right, so finally, let's go down to letter D. Make a statement about what the two distributions tell you about the answer to Ethan's question. Now remember, right, we got to remember what Ethan's question was, and for that we have to go all the way back up. Right? Is gasoline more expensive in New York than in New Jersey? Right? So, what can we say, or what statement can we make to answer Ethan's question? All right, well, I mean, is it more expensive in New York than New Jersey? Well, there's certainly some places in New York that are less expensive than in New Jersey, but it's very obvious that the answer to Ethan's question is yes, okay? And it's pretty easy to see that by looking at those intervals of typical values, right? If we look at the intervals of typical values, right, these are like what you expect, right? They're 2/3 of all the gas stations in New York are gonna have a price per gallon between these two, and 2/3 in New Jersey are going to have a price between these two, and there is very little overlap between these, right? The lowest typical value for New York is 3.49, and that would be really close to the top of typical values in New Jersey. So what I'm going to say here is I'm going to say yes, there is very little overlap between the typical values with the typical values in New York being greater than those in New Jersey. By the way, if you've ever traveled in New York and New Jersey, this is probably what you would find in your own experience. That's primarily due to the fact that we tax gasoline higher in New York than we do in New Jersey, and then that tax gets passed on to the consumer. But that's irrelevant. That's not the point of the problem. The point of the problem is, because the distributions are symmetric, we can easily use these intervals to compare. And because these intervals have virtually no overlap with these values being considerably higher than these values, then we can really conclude that yes, even though it's just a sample of gas stations, in general, gas prices are higher in New York than they are in New Jersey. All right. So when we do statistics, right, and we're just talking about a single variable, gas price or weight loss or whatever, and we're trying to compare samples from two populations, the first thing that we should keep in mind is whether or not those samples are symmetric, or whether they're not outliers or skewed or anything like that that could affect the statistics. Now, once we've determined that, then we have to ask ourselves, well, is the difference between the means or the medians or between the typical value ranges, is that really significant compared to like the variation that's occurring within the data sets? Now, there's some very sophisticated tools that you get into, and you'll get into these a lot more in Algebra 2. For right now, we're just informally assessing whether or not the differences between two samples are significant enough to conclude that the populations from which they were drawn would also have those two differences. In our first exercise today, when we looked at that weight loss drug, there was very little difference between the two medians, right? And we really wanted to use the medians because the means were being affected by that outlier. On the other hand, in the second situation where we had these two beautifully or fairly symmetric distributions, what we could certainly see was when we looked at the intervals that were within one standard deviation of the mean, that interval for New York was much higher than that interval for New Jersey. Okay, well, we're soon now going to be moving on to two variable analysis in statistics in Algebra 1. So we're going to be leaving sort of this one variable behind, but we're going to get into that in the next lesson. For now, I want to just thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.